Okay, so now we're going to talk about cotangent, which is the reciprocal of tangent. And in the case of cotangent, your period will still be the same. However, things are going to shift due to the fact that wherever tangent's defined, cotangent is undefined. So we cannot graph from negative pi over 2 to pi over 2. We need to shift everything. So if you take a look here at this graph, your period will still be pi. But when we shift this from negative pi over 2 to pi over 2, this is now shifted over, okay, so that where your function is now defined will work out for the cotangent. So we're now going from 0 to pi. So you do need to remember that tangent is negative pi over 2 to pi over 2, and the bookends here for the cotangent will be from 0 to pi. So when I take a look at the phase shift, it's still our C value, but instead of it being located in the middle as it was in the table for tangent, it will be now located at the far left as we were used to seeing it in previous functions. So here we have our phase shift, and we would still solve for our value using this bookend method. You notice here these values are different from tangent. Okay, and it must be, your function must be in standard form when you solve the inequality. The beginning and end values will still be vertical asymptotes. We will still find our period of this function by taking pi divided by b, and we will find all critical values, okay, just like we did before. And again, your a value is not an amplitude. It's going to be a stretch or compression. It is not an amplitude. So I'm going to talk about some basic characteristics, and then I'll show you an example. So here we have our cotangent, and again, we're going from 0 to pi, because this is where cotangent will be undefined, and we will sandwich those in between two vertical asymptotes. So I'll go down here to my table. I'll put 0 and pi here, okay, and then I add these two together and multiply by 1/2, I get pi over 2. Same thing here, which is pi over 4. And then when I get a common denominator, which is 2 pi over 2 plus pi over 2, which is 3 pi over 2, times 1/2 becomes 3 pi over 4. Okay, this is a vertical asymptote, this is a vertical asymptote, and this will also be our phase shift for the cotangent. So your phase shift is located here on the left for the cotangent, and remember there's no C value, which matches up here. Okay, so the cotangent of pi over 4 is 1 because it's a reciprocal of the tangent of pi over 4. The tangent of pi over 2 is undefined, which means it looks like this for tangent, 1 over 0. I wrote it really tiny. So when I flip it back over, this becomes 0, and then 3 pi over 4 would be negative 1. So remember the tangent looked like this. Now look at the cotangent. See how they're flipped? So it's like your graph just kind of flips over. Okay, so when I sketch this graph, I'll go through all the pieces, but again, we will have our baseline. So if we have a d value, we will add a to this one. This will be my d value, and this will be d minus a. Okay, so just in general, your domain will be all real numbers where x is not equal to k times pi, where k is an integer. Okay, I wouldn't focus so much necessarily on this, but just so you understand. And that the vertical asymptotes are where x is equal to k times pi, meaning 0, 1 pi, 2 pi, 3 pi, 4 pi, and so on. My range, just like the tangent, is all real numbers, or negative infinity to positive infinity. And as stated before, your period is found by taking pi divided by the absolute value of b, which is equal to pi. Okay, in this case. So let's take a look at the graph. So everything's going to shift. So that means I have a vertical asymptote at 0, and I have a vertical asymptote at pi. Then in the middle we have pi over 2, pi over 4, and 3 pi over 4. And I'm going to use, because I'm on the axis here, I'm going to use this highlighter to indicate my vertical asymptote here, and I'll just do a vertical asymptote here as well. Okay? All right, so then what we're looking for are the stretches, basically, or how low and how high our points are going to be. But remember, they're not in amplitude values. These are not amplitude values. So -1 is at 3 pi over 4, so it's up here. Or excuse me, down here. Woo. And then we have 0, and then we have 1. So I think of this, again, as a reflection of the x cubed graph, because that's what it looks like. And there we go. There we have our graph. Okay, now what's so funny is if this is a reflection, meaning you have a negative out here, it's a tangent graph because it's a reflection. So let's look at an example. We'll look at example 1. Okay, and I've highlighted everything here. So we do have a stretch. We have a d value change. Okay, and we also have a period change. So this is good. All right, so what we're going to do is this right here is not an amplitude, but it is a stretch. Okay, so we actually have to take this into consideration when we're stretching. So we'll do the d plus a and the d minus a. So I'll put d here, d plus a, d minus a as I did before. And we need to sandwich this in between our two bookends. So remember the bookends for cotangent are 0 is less than 2x, which is less than pi. Which means when I multiply by 1/2 or divide by 2, which is the same thing, I end up with 0 less than x less than pi over 2. Okay? So this is my beginning, this is my end. This is my beginning, this is my end. So I'll add the 2 together and multiply by 1/2, that gives me pi over 4. Add the 2, multiply by 1/2, pi over 8. Ooh. 2 pi over 4 plus pi over 4 is 3 pi over 4, so this would be 3 pi over 8. Okay? All right, so now what we're looking at is this. So I highlighted this in orange. That means I have my phase shift. There is no C value, so there is no phase shift, but it makes sense these two should match up. This is a vertical asymptote, this is a vertical asymptote. So I'm going to put this here. X is equal to 0 and pi over 2. This P stands for the period, which remember is pi divided by your B value, which is 2, pi over 2. Okay, and then our vertical translation is -1, meaning we would move down 1. So now what I need are these values. So I have my D value. Okay, so that goes here, -1. Then for this point, I'm going to take my D value, which is -1, and I'm going to add my A value. So that gives me 1. Here, I'll take my D value and I'll subtract, which is -3. So this right here is going to be my new baseline. So when I go over to my graph, I need to put all these things on the graph. So that means I have 0 and pi over 2. So 0 is here, vertical asymptote, 0. And I'm going to stretch this out just so I have enough room, pi over 2. Okay, my middle is pi over 4. And I'm just getting these values from the table that I found on my own. Okay, this is 3 pi over 8. It's a little bit squished. And then here, this is pi over 8. I already have my vertical asymptotes, so now I need my baseline, which is my vertical translation, or D. So I need to move down here, and I'm going to label this as -1. -1. So then I need to move down. This is -1, -2, -3, and that's at 3 pi over 8, so it's down here. Pi over 4 is at -1, and then I need to go up to 1, because from this baseline, I'm stretched 2, so this would go up 1, 2. So this is at 1, and it's up here. So then this looks like it would be a straight line, but you have to put a curve in here. Okay, just like this. And then we're done.